Hi, yes, in this video, I'm going to talk about the nature of the law of large numbers, unveiling the statistical stabilizer. So basically, I want to provide some plain English explanation of the law of large numbers. Introduction. The law of large numbers stands as a cornerstone in the field of probability and statistics. Why? Because it is illuminating the predictable tendencies that emerge from the inherent randomness of data. Rooted in the idea that larger sample sizes lead to more reliable estimates, the nature of the law of large numbers unfolds as a powerful force in statistical theory. A core concept. At its essence, the law of large numbers asserts that as the number of observations or trials in a random experiment increases, the sample mean converges in probability to the expected value of the population. So here converges in probability has certain meaning, as we will see in the weak law of large numbers and the strong law of large numbers. In simpler terms, the law unveils a stabilizing force within randomness. So this is why we say LLN is one of the laws of probability, which shows us how certainty will come out of uncertainty. So if we really want to dig into the mathematical form of the law of large numbers, here we have on the screen the weak law of large numbers. So if we want to describe this in plain English, it looks like the probability of the sample mean and the true mean, that absolute value of the difference of the two exceeds any threshold, no matter how small that threshold is. You look at that probability, it goes to zero when sample size becomes very large. Okay. So in a sense, the sample mean and the true mean will get closer and closer when sample size increases. On this slide, we have the mathematical format of the strong law of large numbers. And you can see it says the limit of the sample mean equal to the true mean. Now that's an event. That event is a sure event. It's like certainty because its probability equals to 1. And this is stronger than the weak law of large numbers. So overall, a plain English explanation for the LLN is, in simple terms, the LLN suggests that with a sufficiently large sample, the observed average or proportion will closely resemble the true average or proportion of the entire population. In probability and statistics, the LLN ensures that with large sample size, the sample statistic will eventually converge as close as anyone wants, and in certain probability sense, to the true population parameters. In this sense, the LLN is the cornerstone of probability and statistics. As we know, statistics is all about studying a sample to learn about its population.